Welcome back to the course Database Management System. And I am Venghaimarbhan, working as an assistant professor in the Department of Information Technology. Uh, in this video, we are going to see about Unit 1, Relational Databases. Already in the previous videos, we discussed the first topic, that is the purpose of a database management system. And in this video, we will cover the topics like views of data, data models, database system architecture, introduction to the relational databases, relational models, and finally keys. So these are all the topics we will cover in this video. Let us begin with a view of data. First, let us understand view of data. A major purpose of database system is to provide user with an abstract view of data. This means user should not worry about how data is stored inside the computers. They should see only what they really wanted. That means what data actually they are needed. This makes the system simple and secure. And why view of data are needed? Views of data are needed to hide complexity, and they are needed to improve security, and they also allow the different users to see the different data. For example, a student uh, can see their more detail or their results. So is um, the data is relevant to the students. They cannot see uh, their staff salary details or some other information. That is called hiding the information to the users. And level of data, there are three levels. So in these pictures, we can mention the three levels: physical level, logical level, and view level. Let us start with the physical level. The physical level is the lowest level. It describes how data is actually stored, and it deals with the files, memory, and disk storage. For example, how an instructor records is stored in the hard disk blocks. The user never interact with this level directly. So, and the next level is the logical level. The logical level is the middle level. It describes what data is stored in the database. It also explains relationships among the data. For example, the instructor has their ID, their name, and the salary. This level hides storage in detail. And in the view level, this is the highest level. It shows only the part of the database to the users, and different users have different views. For example, an admin can see full data. A student can see limited data. That means the salary informations can be hidden for security reason to the students. So these are all the different levels of data. And next we will see the data models. Let us understand data models. A data model is a collection of tools that is used to describe the data and describe the data relationships, they describe the data semantics, they describe the data constraints. And we can see the type of data models. There are several types of data models are available. In that, first one is relational data model, and second is entity data model. In relational data models, data is stored in tables. The tables contains rows and columns. This is most widely used model nowadays. And the second one is entity relationship data model. It is mainly used for database design. So it represents entities and a relationship. The third model is object-based data model. It supports object-oriented features like classes and inheritance. And the next model is semi-structured data model, or in the form of XML. That means the database the data does not contain any structures. That means it does not contain any fixed structures. Um, and there is no rows and columns for the data. The schema can change easily. Data is self-describing. It supports nested attributes. And mainly it is suitable for web and distributed applications. Examples of semi-structured data models are XML and JSON. And finally, there are older models are available, network model and the hierarchical models. So network models is organized data using a graph structures, and hierarchical models is used to organize the data in the tree-like structures. In the network models, records are connected as a networks. There is no strict tree structures, and it is more flexible than hierarchical model. In the hierarchical model, each child has only one parents. Relationship is one to many, and the data is accessed top to bottom in the hierarchical model. Here, one of the example for relational model. In the relational model, uh, it is the employee details. The employee tables contains attributes. Those are mentioned in the column, like ID, name, department name, salary. And each attributes contains its tuples in a row wise. And come to the next topic. It is database system architectures. Mm, it is used to explain how database systems are organized and designed. And database system architectures mainly consist of four components. They are users, query processors, storage managers, and disk storage. So we will see the one by one in detail. In first, users of database system, there are different types of users in a database system source. Naive users, application programmers, sophisticated users, and database administrators. In naive users, uh, use the predefined applications. Actually, they are interact with the system with the application interfaces. They do not know the SQL is used to interact with the database. That means they cannot directly use the SQL to the uh, retrieve the informations. In this examples for the naive users, bank customers, ATM users, and web users are the naive users. And the application programmers write the program using high-level languages, Java or Python. They are embedded with the SQL queries inside the program to access the database. And sophisticated users, they can use the queries. The sophisticated users use the query tools directly. They can write the complex SQL queries. Examples include a data analyst. Uh, they can interact with the system through the queries. And the database administrators control the databases. They can handle the security, backup the data, recover whenever whenever the system got failure, and they are permit the users with the authentications. So these are the different kinds of users. And come to the next part in this structure, it is query processor. In the query processor, it converts the high-level queries into low-level instructions. So in this, there are uh, uh, different parts are available. That is a DDL interpreters, a DML compiler and organizer, application program object codes, um, query evaluation engines, DML queries. So these are all the parts are available in this section. In that, a DDL interpreter is used to uh, uh, handle the commands like create, alter, and drop. It is used to store the schema details in the data dictionary. And a DML compiler and organizer is used to convert the DML queries into execution plans. So, for example, of DML commands like select, insert, update, and delete. And the query evaluation engine is used to optimize the query plan. So it is used to retrieve the recorded data with efficiently. And another part is storage manager. So in this part, there are some managers are available: buffer manager, file manager, authorization and integrity managers, transaction managers are available. So in this, uh, storage manager is act as a bridge between the query processor and the disk storage. So in that, buffer manager is used to handle the data transfer between disk and the main memory. And a file manager act as a um, the file manager is manages to storage space on the disk. This organizes the data files. And authorization and integrity managers, uh, uh, it is used to check the user permissions, and it enforces the integrity constraints. And the transaction managers, ensure the as if properties. That means atomicity, consistency, isolation, and durability. It handles the commit and rollback operations. Whenever the system got failure, the transaction manager will start to roll back the system. And finally, disk storage. The disk storage contains uh, it contains actual data records, indices, which is used to speed up the access, and a data dictionary, which is store the metadata, and statistical data, which is used to query optimization. So these are all the parts available in the database system architecture. And we are moved to the next topics, that is introduction to the relational databases. Let us understand the relational databases. So in the relational databases, all data is stored in the form of tables, and each tables contains rows and columns. Rows are called tuples. The columns are called attributes. Here, ID, name, department name, salary are the attributes. So those attributes contains several tuples. Like in ID attributes, it contains a tuple 10101. So this is one of the ID of the employee. And name attributes, it contains one of the name. It is Srinivasan. And department attributes, it contains one tuples, that is a computer science department, and the salary of the employee. The salary is also one of the attributes, contains the tuples. So the value 65,000 is the tuples. So another one examples for relational data models. Here the instructor table and department table. And we move into an important topic, that is a relational schema and relational instance. The relational schema defines the structure of the table. It is specified table name and attribute names. For example, instructor table, the instructor, the attributes of with their ID, name, department, and salary. The schemas are rarely changes. And instance, relation instance represent the actual data stored in the table at the particular time. Whenever the data is added or updated or deleted, the instance can be changes. Each row in the tables is called a tuple. Tuple like the roll number, it contains 101. So in the previous slide, we already discussed. So tuples are row values, and attributes are column values. And come to the attributes. And attributes represent a column in a table, and it is also called the domain of the attributes. It is set of allowed values for an attributes. For example, salary must be an integers. Like ID, ID is the attributes. Its domain is comes under the integers. Salary is the attributes of the employee or instructor. It comes under the domain of integer. Then name is one of the attributes of the instructor or employee uh, or in the student table. It comes under the domain of string. So these are all the attributes. So in this, atomic value is defined. This means they should not be divisible. And come to the null value, whenever the value is missing or the unknown values or the values uh, 0. So the null value is represent for the unknown or missing values. Create the complication in database operations. So null is different from the 0. And come to this slide, I will discuss about the keys. And this is the final topic of this session. Key in DBMS, keys are attributes or a set of attributes is used to uniquely identify the records, that is tuples in the table. They play the vital role in the data integrities, relationships, and efficient access. The keys is used to uniquely identify each records to avoid the duplicate records, and it can maintain the data consistency, and it can establish the relationship between the tables. Different types of keys are available. In that, first one is super key. A super key is a set of one or more attributes that can uniquely identify a record. For example, in the student or in the instructor table, ID and ID comma names are super key. So it may contains extra attributes, that is called ID comma name. In the second one is candidate key. It is the minimal of the super key. So it contains no extra attributes. For example, here the ID is the candidate key. The ID comma name is the extra attributes that is not allowed in the candidate key. Remember, key is used to uniquely identify the particular tuple in the table. And come to the next key is the primary key. So in a particular table, there is only one primary key is available. So which is used to identify the record in the table, and it should be the value. That means it cannot be null. It must be unique, and only one key is per table. For example, instructor instructor ID. For instructor table, the ID is a primary key of the table. And the last one is foreign key. So the foreign key is nothing but a key is attributes that refers to the primary key of another tables. For example, here instructor and a department, the both table are referred by the department name. So the department name is the common identity of both tables. So here the department name is the key, so which is called as foreign key. So these are all the topics we covered in this session. From this video, you have some basic understanding of view of data models, database system architectures, and relational databases, relational schemas and instance, attributes and domains, and finally keys. In the next lecture, we will study about the ER model and the database design. Thank you.